Good morning, students. Today, I would like to discuss another question for the board point of view. That is intensity of electric field at a point on the equatorial line of an electric dipole. So, as we know that the difference between the axial line and equatorial line. Number one, axial line means the line passing through the two charges on an electric dipole is nothing but the axial line. Whereas equatorial line means the line passing through the center of the electric dipole and perpendicular to the axial line. See, look at this one. These are the two charges. One is negative charge, another is positive charge. These two are separated by distance 2a. Then this can be known as electric dipole. Got it? Now, the line passing through the center of the electric dipole, this is the center point of the electric dipole. This is the line passing to the center of the dipole and perpendicular to the axial line. As we know that this is the axial line. So, now this is perpendicular to the axial line passing to the center of the electric dipole, which we can call as equatorial line. Now, I would like to determine the electric field intensity on this equatorial line at a particular point. That is a question. For this point of view, here I am considering an electric dipole named as AB having the charges plus q and minus q separated by distance of 2a, and the dipole moment is represented by the capital P, which is nothing but the product of q and 2a, that is charge and the distance between the two charges. Now for this explanation, let a point C on the equatorial line, this is the equatorial line, at this particular point C, which is at a distance r from the O, as shown in the figure or diagram. Now to determine this, now place a unit positive charge at a C to determine the electric field intensity. Now if you observe this is negative charge, this is positive charge. That means there must be a force of attraction will be present. Here in this case positive charges, the force of repulsion will be present. So that electric field in this case, the electric field direction will be towards the point A. This is electric field E. Due to the negative charge, that will be towards the point A. What about this one? For this case, the electric field intensity will be away from the C. That means in this direction electric field will be present. That is E. Now, at this point, it will making an angle theta with this. Now, this may be, now for this, due to this electric field intensity will be in this direction, which is making an angle theta with this horizontal. This is say E1, this is E2. If you observe this, the C point is at a distance from the negative charge is, it is a right angle triangle. Let us say this is A, this is R value. Now by using the Pythagoras, you can write hypotenuse square is equal to side square plus side square. You will get a root of R square plus A square. Same thing for this also. R and A, this is under root of R square plus A square. So distance is same. The electric field will be in this direction. For this, electric field will be in this direction. Now resolving this, for this electric field in this direction for the E1 will be like this, E cos theta, let us say E1 cos theta. For this is also making an angle theta. Now same theta equal theta value. Now for this E2 cos theta. That means the resultant of these electric fields E1 and E2 will be in this direction. That we can say E1 cos theta plus E2 cos theta. So we can say that resultant electric field at point C. So we can write here resultant electric field intensity at point C is E is equal to, you can write E1 plus E2, that is E1 cos theta plus E2 cos theta. Here you have observed E1 and E2 are same. Why? Because distance is same in both the cases. That means you can simply write E equatorial is equal to simply 2E1 cos theta or E2 cos theta, whatever it may be. This you have to find. As we know the formula for the E1, so electric field intensity for a point charge. So you can write electric field intensity due to point charge E is equal to the formula, that is E1 or E2. E is equal to, the formula is 1 by 4 pi epsilon naught Q by R square. R square means under root of R square plus S square whole square. That means you can write under root of R square plus A square whole square. Square root get cancelled. Finally you can write E1 is equal to 1 by 4 pi epsilon naught Q by R square plus A square. This is the formula for the electric field intensity. Capital E1 or E2, both are equal. Now, what from this diagram AOC, you can find the cos theta also. So, from triangle AOC, cos theta is equal to adjacent side by hypotenuse. Now the adjacent side here is A. By hypotenuse is this one. You can write R square plus A square, root means whole power 1 by 2. This is the value of cos theta. Now finally you can easily determine from this formula. So you can get E equatorial is equal to 2 into E1 means 1 by 4 pi epsilon naught Q by R square plus A square into cos theta means A by R square plus A square whole power 1 by 2. Now substituting will get E equatorial is equal to 1 by 4 pi epsilon naught Q into 2A by, this is power 1 by 2, that is bases are equal, power should be added. So we'll get R square plus A square whole power 1 plus 1 by 2, that is 3 by 2. But we know that dipole moment P is equal to Q into 2A. Now in place of Q into 2A you can put P. Got it? Now substituting, finally you will get E equatorial equal to 1 by 4 pi epsilon naught P by R square plus A square whole power 3 by 2. This is the final formula for the electric field intensity on the equatorial line at a point C. Now for small dipole, A is very less than R. That means remove the A value. What you will get? 2 cancelled. So A, if you remove the A value, that means R square whole power 3 by 2. 2 gets cancelled, we will get R power 3. So we can get E equatorial equal to 1 by 4 pi epsilon naught P by R cube. That's it. So already we know that for E axial is equal to 1 by 4 pi epsilon naught 2P by R cube. That means from that relation you can write finally here E axial is equal to 2 into E equatorial. This is the relation between axial and equatorial line in case of the electric field intensity. Same thing for the magnetism. In magnetism also same thing you can get. Magnetic field induction capital B also same, the relation, having the same relation also, but we can check it later about that. Thank you for watching.